The next example we're going to do in our adventure on recursion is factorial. So hopefully you've already seen factorial before, but the factorial of a natural number n is the descending products from n down to 1. So, for example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Okay? Now, hopefully you can already see why this is recursive. 5 factorial is actually just the same thing as 5 times 4 factorial. Hopefully you can see why, because 4 factorial is the same as 4 times 3 times 2 times 1, which is what we have right here. So the recursive substructure is the exact same. Now, how can we define this with a base case? So the base case of factorial usually depends on who you're talking to, but we're going to say that the base case is 0 factorial, which is 1. Okay? It's also true that the base case, or that the factorial of 1 is 1, but because we're going to be using those 3 methods, add 1, sub 1, and is 0, we're going to make our base case 0 just because that makes the code a little bit cleaner. Okay? So let's begin. So what do? Well, first thing again is we have our base case. So if is 0 of n, and we'll just copy these methods in. So if n is 0, then we're going to return what? We're going to return 1. Okay? Otherwise, we're just going to return, what did we say? We said n times the factorial, well, we didn't actually write it down, but n factorial is equal to n times the factorial of n minus 1. Okay? And then n factorial is equal to 1 if n's equal to 0. Okay? So that fully defines everything. This is our base case, and then this is our recursive step. Okay? So we're going to do n times fact of n minus 1, and then hopefully our test will pass. Let's see if we can get this to run. It does not want to run. This is a good debugging time, so we can fix this by just saying which tester we want to run. Hit apply, hit run, and all tests pass, so we're good. Okay, so we have our base case here, and then we have a sort of implicit base case of 1 factorial being 1, and then we have just a standard example here of 5, which is, or would be, 120.